So we're going to start by talking about composition of functions here. And what a composition of functions is it's where we're going to take two functions and put them together. But first, what I want you guys to do, we've been doing this already. We're going to practice in function notation. We have f of x equals 2x plus 10. And I want you to go ahead and plug in f of 3 and solve. And then we have g of x equals 1/2 x minus 5. So I want you to plug in like g of 12 and g of 5. So I want you to work on those first 4 problems, just substituting and simplifying and seeing what you come up with. And we'll talk about them in just a second here. All right, but take a couple minutes to work on those first 4 problems now. All right, so for problem 1, f of 3 equals 2 times 3 plus 10. It's just saying, this is pronounced f of 3, it's not f times 3 or anything like that. So f of 3, so it's just saying we're going to replace all the x's with 3's. We get 2 times 3 is 6, plus 10 is 16. So f of 3 equals 16. If I were to write as an ordered pair, this would technically be 3 comma 16. That'd be the point on the graph. To represent 3 comma 16 right there. That's how I'd rewrite this as an ordered pair. That's the idea for these types of problems. G of 12, 1/2 of 12 is 6. And then 6 minus 5 is 1. G of 5, third one, 1/2 of 5. This one gets a little trickier. It's going to be 5 halves. So I have 5 halves minus 5. And I want to rewrite 5 halves. I'm going to rewrite it as 10 halves. So it's the same number, but with a common denominator. Because I can't do 5 halves minus 5, but I can rewrite 5 halves as 10 halves. 10 divided by 2 is 5. And now I can simplify this problem. 5 minus 10 is negative 5. So this becomes negative 5 halves. That'd be g of 5. That's how I would simplify this algebraically. Okay. The very last problem here, f of 3a plus 4. Sometimes it is possible that you just get another variable to plug in instead. And we would just start by using distributive property. 2 times 3a is 6a. 2 times 4 is 8. And then 6a plus 8 plus 10 is 18. So 6a plus 18 would be the simplest form of problem 4. So it didn't really simplify the problem too much for us, but that's how we'd rewrite it. All right, in terms of a now. All right, so that's the idea for function notation, which we've gotten practice on that on the graphing problems when we did our graphing quadratics and you had to find a 4th or 5th point. You would have to do that a couple times. All right, with radical functions, you need to plug in a value and solve. All right, so we've seen that type of problem before. Now, what we're talking about today specifically is composition of functions. So the definition of a composition of functions, I'm going to put an S there, that's a little typo. It is using the output of one function as the input of another. So using one function The output of one function is the input of another. We'll take a look at an example of what I mean by that. But first I'm going to show you the notation. The notation appears as f of g. It looks like a little circle of x, or we might see it written like this, which I personally like the second written way a little bit better. But it looks like the word fog, so you might hear fog for f of g of x, or goff for g of f of x. But we can see it written down here, like f of g of x. That's the little circle you see. It's almost like when you write down degrees, like 38 degrees. It looks like that degree symbol, except it's that kind of circle there. Okay. So f of g of 2, we could technically rewrite that as f of g of 2. I'm going to rewrite it like that. And what that's saying is, hey, whatever the f function is, we're going to take this, we're going to replace all of the x's from f of x with g of 2. But what we need to do first is we need to figure out what's g of 2. So we'll start with that. G of 2 is 2 times 2 plus 1, and that's coming from this equation up here, g of x. And we simplify that. 2 times 2 is 4. 4 plus 1 is 5. So this is saying, hey, g of 2 is the same thing as 5. So when I look at f of g of 2, I could also be saying f of 5. So I'm taking the output of the g function, the output is the y value, that's the 5, and I'm using that as the input of the f function. That's what the definition of a composition of functions says. The output of one is the input of the other. All right, so that's the idea here. So I would just go back to the f of x and say, okay, well, f of 5 is 3 times 5 minus 4. And then simplify that. 15 minus 4. 15 minus 4 is 11. So f of 5 equals 11, which means f of g of 2 equals 11. So that's how I would do this type of function, a composition of functions. Okay, so you figure out what the output of the first function is, and then use that as the input of the second function. So I like rewriting it first. We'll do the second example now. I like rewriting this as g of f of 2, because then I can see, okay, well, what's the inside function? The inside function here is f of 2. And that's what I want to start with. I want to figure out what's f of 2 first. And now what we're doing is we're going to compare f of g of 2 to g of f of 2 and see, like, hey, are these the exact same thing? That's what we're going to kind of look at here. Okay. Oh, so this question says, how did I get a 2 for the distributive property on number 4? So real quick, on number 4, I had a 2 there because the original function was 2 times x plus 10. So that's where the 2 came from. It was just replacing the x with 3a plus 4 and then plus 10. That's where the 2 came from on number 4. Okay. And then we went ahead and did the distributive property there. Okay, let's put that in. All right, now for part B, let's go ahead and solve this one. F of 2 Because 3 times 2 is 6 minus 4. So f of 2 equals 2. So that means when we get to g, we're saying g of f of 2, the output of f of 2 is actually 2. So that's the same as g of 2. And we know g of 2, we actually already did that one on the previous problem. That should be a 5. And it is. So g of f of 2 is 5. And what we see here that's really an important thing to note is that f of g of 2 did not equal g of f of 2. They're not the same thing. F of g of 2 is 11. G of f of 2 is 5. They're getting different outputs. So it is possible that sometimes you'll end up with the, it is possible that you will end up with the exact same values, but not always, okay? So in this case, definitely not. Most of the time, you're not going to end up with f of g of 2 equaling g of f of 2. Sometimes it will happen, but not very often, okay? And we'll talk about that later. There are specific examples where that does happen. Okay. Now what I want you guys to do, I've got examples A, C, and E here. Skip B, D, and F for now. We'll go over those ones together. But I want you to try these out. F of G of 5. And then G of F of 5. And then the last one, kind of a weird one, G of 5. You're just going to plug G back into itself. So try those three out. I didn't leave you a lot of space on E and F there. My apologies. Just bad spacing. All right, but try those three out now. All right, so I've showed you part A already. Let me show you part C now. We'll say f of 5 is 3 times 5. So f of 5 is 15. So g of 15 is what we want to figure out. That's 2 times 15 minus 6, which is 30 minus 6, which is 24. So technically g of f of 5 is 24. That's the idea for part C there. The very last one, these ones I think are a little bit easier because this one's saying we want to do g of 5. So what that really means is first we want to find g of 5, which technically we already did that in part A. So I'm just going to write that down. That's from part A. And then the second part, we're going to take that output and we're going to find g of 4. So we're going to plug in 4 into the exact same equation. 2 times 4 minus 6, that's 8 minus 6. So g of 4 is 2, which means g of 5 is 2. That's the idea for part E. We're just finding the output of g, and then we're plugging it back in again, using the same number again a second time. Okay, so now what I want to show you guys is the second part, parts B, D, and F. It says express f of g of x as a single function. And what that means is we want to take g of x, all right, just straight up g of x, and we want to input that into f. So that's very similar to what we did on problem 4 of the very beginning today of like our little warm-up. I'm going to say f of 2x minus 6. I'm going to replace x with 2x minus 6. 3 times 2x is 6x. 3 times 6 is 18. So we get 6x minus 18. That's f of g of x. And what that does is that combines the functions in general, like a general form of the functions. And that can save us steps along the way. What I mean by that is, now let's say that I asked you again to find f of g of 5. We could technically plug in 5 into this consolidated equation. 6 times 5 is 30. 30 minus 18 is 12. F of g of 5 is 12. We just got the same thing on part B as we did on part A. F of g of 5 equals 12. So what's happening there is in part B, we're finding a general case, f of g of x. Because like if I asked you, hey, find f of g of 5, and you go ahead and find g of 5, and then you find f of 4, and you get 12. So you can do that. But then I said, okay, now go ahead and find f of g of 3. Then you have to find g of 3, and then you have to find f of the output of that. So it would be a lot of steps if I kept asking you to find things. But if I said, hey, find f of g of x, okay, you get a general equation, 6x minus 18. And now I say, find f of g of 5, find f of g of 3. It'll be super fast to do that. Because f of g of 3, I would just plug in 3 here and say 6 times 3 is 18. 18 minus 18 is 0. F of g of 3 equals 0. It would solve a lot faster for me. That's the idea of finding a general rule or expression for f of g of x. It's going to solve a whole lot faster for me. Okay? That's what part B, D, and F are kind of getting at. We'll do one more example here. G of f of x. And we're going to write the general rule there. So we're going to take the g function and we're going to plug in 3x into it. That's what f of x is. And that means we're going to say 2 times 3x minus 6. Six x minus 6. G of f of x is 6x minus 6. Okay, that's what part B would be. And then if I just tested it, g of f of 5, I should get the same answer of 24. And sure enough, I do. G of f of 5 is 30 minus 6. That's 24. So it checks out. Okay, that's part D. Now I want you guys to try part F. Do g of x. See if you can come up with a general equation for g of x. So take a minute and do that. So that's how you'd end up with the result for part F with g of x. All right, now I've got 6 problems here. F of h of 5, g of h of 5, h of f of 5. And then f of g of 5, f of g of x, and g of f of x. I'm going to ask you guys to work on those 6 problems. If you want to, you could do like 5 and 6 first, so like f of g of x and g of f of x, because that might help you save time on something like problem number 4. That's definitely an f of g of x type problem. All right. And you could also do like an f of h of x and see if that helps you simplify things first. It's entirely up to you, however you want to approach these problems. But just get some practice putting in the input, solving for the input function, and then stepping up and solving for the output function. All right, so you're given 3 equations here, f of x, g of x in blue, and h of x in green. All right, so take a few minutes to work on those problems now, and I'll go over them with you guys in just a minute here. And again, keep asking.